So we're back on the New York State Education Department website for the Computer Science and Digital Fluency Standards. Here we are going to again go down to the grade band for Computer Science and Digital Fluency Standards, grades 2 and 3. We're going to scroll down till we get to page 4 that's going to go through the computational thinking strand. This is the largest of all the strands. You can see that there are 10 standards within this concept area, broken down into 4 sub-concept areas. The first one is modeling and simulation. Here we're looking to create a model of an object or computational process in order to identify patterns and essential elements of the object or process. The emphasis really is on data represented in a model to portray results and to assist in identifying patterns in the world around us, which is definitely something we do in grades 2nd and 3rd. We think about patterns. And then we're going to move on to data analysis and visualization. Here we're going to identify and describe data collection tools from everyday life. So think about the various tools in everyday life that collect, sort, and store data. So you can use surveys, spreadsheets, and charts. And then in CT3, we're going to present the same data in multiple visual formats in order to tell a story about the data, which is really important at grades 2 and 3 to understand the information. The emphasis here is on using visual representation to make the data meaningful. This could be charts, graphs, tables, anything to actually make the data be presented visually. In abstraction and decomposition, there are 2 standards. The first one is identify multiple ways that the same problem can be decomposed into smaller steps. So here you're identifying how to break apart a problem into smaller steps while understanding that there can be multiple valid sequences of steps to solve the same problem. You probably already do this in math when you think about different ways that you can organize data in order to figure out the problem. And then in CT5, we're talking about identifying the essential details needed to perform a general task in different settings or solutions. So some details are essential in performing a task while others are not. For example, some may be so common that they don't need to be stated. So you can think about the ways you break down a math problem, or you solve a question, or where you find information, and think about the tasks that you do to get that information. Finally, we have algorithms and programming, and this is the largest area of all of the concept strands within computational thinking. Here we're going to look at CT6, which is create 2 or more algorithms to complete the same task. The task can be a familiar activity or more abstract. The focus is on finding more than one way to reach the same goal. So you might talk about the path that you can take from student desk to the door, or it might be steps to solve a math problem, or ways to break down a word or define a word, something along those lines, where you're thinking about the steps it would take to define, to be able to solve a problem. As we move into CT7, we're naming, labeling key pieces of information in a set of instructions, noting whether each name label refers to a fixed or changed value. The focus is on identifying key pieces of information, labeling them with a descriptive name, and observing which labels refer to different values each time the instructions are given, and what values stay the same. So again, we're really trying to figure out or abstract a meaning based on what we have and what we need to have in order to get the results that we're looking for. As we move into CT8, we're identifying steps within a task that should only be carried out under certain precise conditions. The focus should be on recognizing that some steps in a task only get carried out some of the time, and that the conditions can be precisely described. As we move into 9, we're talking about debugging here, identify and debug errors within an algorithm or program that includes sequencing or repetition. The focus should be on having students identify an error in the algorithm and suggest changes to fix that algorithm. So let's say they're putting together a recipe, or they're following a step-by-step procedure for, say, origami. They have to be able to figure out when they make a mistake and what they need to do to fix it. And then the last one, CT10, is develop and document a plan to outline specific steps taken to complete a project. The focus should be on developing and documenting a plan in writing using appropriate tools. So this could be storyboarding or story maps, or following a sequence of things that have happened within a story. So that is computational thinking.